Okay, welcome back, everybody. I think we've had some incredible talks this morning, ranging over quite a broad spectrum of things relating to the underground. Now we're going to get a little bit more into digital twin. Alex Chales, who's really had a lot of experience in this sector, smart cities. I don't know if you remember a few years ago, there was a project in Toronto, I think by the Toronto Region Board of Trade. It had a smart city working group, and Alex was involved in that. And I think right now he's also involved in a smart city project in Zurich. So this is something that's happened. I mentioned at the beginning that a number of cities have realized that if they're going to put together a digital twin of the above ground, they need to start seriously thinking about the below ground as well. And I think that really has percolated through a number of cities. So I'd like to welcome Alex and to talk about what UEVO is doing in this area and how it would be useful for anybody who wants to create a digital twin of the underground.
Thank you, Jeff, for this great introduction. Let me start sharing the screen first. So Huevo is a company that we have created specifically for the digital twin for subsurface infrastructure. Just to introduce both of us who are going to present today, Antoine Castel is my co-founder. Yes, he is in charge of our business development, and I myself in charge of basically putting this product and the platform together. So let me go straight into the presentation and also address a couple of important issues regarding the digital twin. So from the start, there are a number of slides here that everybody who has presented before us have highlighted all these great and important points regarding the need for the actual infrastructure and the lack of a unified model or unified platform that allows to bring all the data together. So we're going to breeze through this slides, including some of the experiences that we have monitored both here in Switzerland, where we're now, in Canada. When I was 2 years ago, we were living in Toronto, and in other places like Vancouver and other, including the very important regulator initiative from London with the creation of the National Underground Asset Register. So as everybody knows, the most important pieces that are missing in the whole puzzle of putting this together are depth coordinate on a lot of infrastructure, including also very difficult ways of how to work with some of the models or some of the maps that have been created. So when we looked into this current state of underground infrastructure, we saw a really good merger with the technology that we have created and have managed over the last almost 20 years, that has been used primarily in large-scale simulations and games. And please don't be scared of the gaming environment itself, but our technology has a number of unique features that actually provides great benefits for anybody that is trying to put together a digital twin of the infrastructure. The title of the presentation about whether digital twin is real or not is a little kind of a question we wanted to ask and answer during this presentation, as you will see. So what is our approach? Our approach is based on the development and creation of very large scale three-dimensional environments. Could be the scale of a block, could be the scale of the city, and potentially could be the scale of the whole planet, where all the users and stakeholders can collaborate and use the information that is available there. There are a number, obviously, of aspects, and thanks to Paige's question and answer regarding the security, because that's definitely a big concern. We can address that in the later slides, but the main benefits of the approach that we're taking are related to the collaboration and multi-developer and user environments. Then live updates, which we are going to demonstrate straight during this presentation. Real-time data feed, so basically any sensor data that is available to either municipalities or utility owners or operators can be directly displayed and visualized within this environment in real time. Precision, we are mentioning here 3 to 5 centimeters, but actually it depends on the equipment that is being used, whether it's GPR or photogrammetry or other equipment that actually collects the data. Persistent environment is extremely important feature, we believe, for the digital twin to exist. And one side note on the digital twin, it is our belief that unlike many of the 3D models that have existed are being built, digital twins are different because they do reflect the changes in real time of the underlying assets, life and behavior. So in the building a persistent environment is extremely important, because whether you are part of this environment as somebody who provides the data, somebody who, or as a user who reads the data, or you are away, everybody who is the contributor to that environment can continue to grow that environment in real time, and you will see those changes appearing straight in front of you when you are using the platform. The other important piece is obviously the newest technologies that we have seen, VR, AR, and other mixed reality opportunities that can be explored in addition to just being able to view and use this model while you are sitting in front of your computer or using your tablet in the field. Some brief overview here on the comparisons, and we're not going to go much into it, but one of the important points that we wanted to really highlight are this multi-developer environment, which allows in real time multiple contributors to bring in the data, and also real-time nature of the platform, where as similar to the previous presentation, we have the platform that is hosted on AWS and fully protected from security point of view on one side, but at the same time also allows for any number of developers or users to join in the platform and either contribute or use the platform for their own purposes. I will pass to my colleague Antoine to cover the technology.
Thank you, Alex. Next slide, please. I would like to just describe you quickly how we build this model. What we import in that 3D model is in that 3D digital twin is quite important. It reflects the reality of the surveys that are done on the ground. So we first collect existing information based on cadastral maps or BIM models, etc., whatever is available from the stakeholder. LiDAR scans for above the ground for better representation of the reality, and to connect what's below the ground with the facilities above ground, the manholes, the fire hoses, electric boxes, etc. And for large-scale projects, like some we will be demonstrating later on, ground penetrating radar to detect infrastructures in more crowded areas. We also have the possibility of connecting live feeds from IoT sensors in the real world into the digital twin for better representation of what's being collected and what's happening live. Next slide, please. So the platform we have created is, like Alex said, a 3D real-time environment that we can scale to any dimension. a building, a street, a city, a country, a planet, where we import existing data and existing surveys, being quite agnostic to the sources. We can display all documents, either PDF or 3D models, supporting at simultaneous multiple developers and users. So we will be demonstrating that a little bit later on. You can work on the same model, same pipe, same city, same road at the same time from all across the country, all across the world. It is very easy to maintain because of that. It is really easy to update because of the agnostic aspect of the platform. And also this environment is persistent. So it does not shut down when you shut down your computer. It lives on the cloud and enables the real tracking of the data. How that platform has been built, like Alex mentioned, it was originally made for very large simulations and very large multiplayer games. It connects all the tools that you would need to create such solutions. The networking of the servers are hosted either in the cloud in AWS or locally, depending on the requirements of the client. If it's a municipality who wants to own, or the regulation in a specific country or area that specifies that one stakeholder is the owner and that data should not be displayed to others. The data can also be stored locally. We enable the following of the versioning of every modification in the models, and at the same time you can have a limited amount of simultaneous contributors, either stakeholders, workers on the ground who want to update the model, or city planners, managers doing planification, or just checks and simulations on the models. And at the same time, users to visualize and to verify the data. So just a quick word on the technology side and the very popular word BIM. We are not a design and conception solution. We are visual data, let's say visual database for visualization, simulation. So we are of no use for BIM models in the concept stage with all the physics and all the specifications of materials to plan. It is not the purpose of our solution, but it is the purpose of our solution to be useful after the infrastructure has been built, importing all the digital models, updating them and their position, their exact position with surveys, and enable the multi-user collaboration on those models, and enable real-time updates whenever there is a change, when there's maintenance or when there's damage.
So let's talk about the benefits of the digital twin and what do we bring to the table. And I know there were some there was a little bit of skepticism about the whole representation in 3D environment when we're already reading some data. And as previous presenters have shown, the collection of data is already happening in 3D. And we believe that it's kind of a waste not to use 3D environments that have been used in many industries before, in order to display that information on one side and work with that information as well. So in addition to just simply displaying the information, our platform allows for that real-time collaboration. What that means is, if a telecom company today starts laying somewhere fiber cable, and at the same time the water company is looking at that model, when the final surveyor signs off on the works that have been done and the model is updated, everybody who participates in that specific area, city, will see those changes happening in real time. The other most kind of important things that we have realized while we were working with the local multi-utility companies and municipalities, they are missing a tool that would allow them for much better planning of the new projects. Not knowing exactly where the pipes are. According to the CEO of one multi-utility company, he says as soon as we start digging, that about 90% of plans have to be thrown away or redrawn because we find stuff that we didn't know that actually exists underground. And we're talking about Switzerland, where, as many of you probably know, they have a very rigid replacement cycle. About 3% of roads are replaced and refurbished every year. So over the 30-year period, you replace more or less every road that exists in the country. Still, they're missing quite a lot of information. So better planning opportunity that allows you to actually put your infrastructure, if you want to update or replace existing infrastructure, exactly in places where you have space, and at the same time not to disrupt the existing infrastructure that is delivering vital services to the communities. As Antoine mentioned, we are agnostic to data. We don't really care where the data is coming from, as far as it is either three-dimensional data that can be displayed and visualized on our platform, or it is a data that can be attached to three-dimensional objects. So additional data about location. The platform itself is built in a way that you can have proper GPS location for every object that you see on the platform, and then you basically can connect also additional data sources that would provide, that would increase the usability of this information. And one word in general about this three-dimensional data, and everybody knows how heavy and big it is and how difficult it is to actually visualize it and use it, because like with all the other information that we have seen in the internet age, three-dimensional data is being collected now, and we will see an exponential quantity of that data. So we need to find tools that will allow and enable us to actually use that data and manipulate it on a really large scale, because that the fragmentation that we have seen while working with different counterparties of the data that they own, and the lack of sharing actually leads to all the many of the accidents that previous speakers have highlighted. One of the important also aspects, as we said before, not only simulating and planning, but also emergency training and other things that could be related to improving the resiliency of your infrastructure, could be also the platform can provide you with additional support in developing those scenarios. So we have talked already on the kind of direct benefits of the platform as far as shared reliable database and decreased potential operational public risks. There was one question about savings, and a great example about 90% lower accident rate. At the same time, there are other savings that obviously indirect savings, and which would be related to insurance costs of those of the infrastructure itself, better planning, decrease the amount of time before you start construction. Having all that information, one can start projects a month or 45 days ahead of time using traditional methods. And the other thing is important, obviously, is the minimizing the impact on the local communities from any kind of disruptions that are potentially going to interrupt services within the area. So with this, I would like to, Antoine, if we can start, if we can do a demo for everyone to see what we're actually talking about.
If you can allow me to share my screen.
I stopped sharing. While Antoine is going to start sharing the environment, I would like to mention one thing that there was a little concern about the kind of the generational change and the user base today of the platforms like this obviously consists of engineers with long life experiences in this. At the same time, the new generation, they do live in three-dimensional environment and primarily in virtual environments, whether it's gaming or other platforms that exist. And as scary as this might sound, within the next 10, 20 years, they will be the ones who will manage this infrastructure. So providing them, as we are already collecting the data, providing them with that environment where they feel natural and actually can use it to the best degree of their skills is one of those steps that we believe has to be undertaken already now, because building out these digital twins in three-dimensional view is going to take years. Anyway, so let's go ahead with the platform.
So with a bit of context, this is an upcoming project happening in Las Vegas. So it's a piece of land that will be refurbished and reconstructed. We are dropping here with 4 different instances of the 4 different sessions of the platform. I am here in the southwest of France. Alex is present as well in the environment. He's in Zurich, and the servers are for this specific project are located just outside of Washington, DC. So everything that you will see is done live, and the updates are done live, and you will see that the communication happening across the pond is quite fast. So just to give you a little bit of area view, here on top left of your screen, you will see the actual area where we have built upcoming buildings. And also, if I can dip a bit down in the ground, we also have built the subsurface infrastructure connecting them all. The purpose of this demo is not to show off any visual tricks, but just to demonstrate how easy it is to collaborate and work on the same project. So I will be using the session here on top right of your screen. I'm going to select a pipe here, and I can modify its position quite easily. And you will see on all the screens, all the others, that the update will happen as soon as I drop my mouse. So here I can move that pipe around. I can change its color. I can change its markings. And if I move to the session down here to the left, I can move the same pipe, and I can modify it. And with the third, I can do exactly the same. And you see the every update happening live for all participants. So as Alex mentioned, and as was previously said in other presentations, this is a solution where we can implement rules. So here I am all power because I am an admin, but I can attribute specific rights to specific contributors to the platform. So there is no limit to what can be done there. Just the amount of infrastructure and the amount of work that has to be done on the same day can be reduced a lot if one can be working also in these times remotely, but all working on the same models. I can change their size, obviously. I can rotate, I can change their position, I can rotate them. It is not a problem, and I can keep the tracking of their exact position.
So as Antoine mentioned, we are in Europe, in different countries. What you see visualized in front of you not only crosses the pond once, it actually crosses the pond 3 times. So when we work with the cloud, and it is also on AWS, we make the changes. These changes then come back and are seen by all the contributors on this platform. And then we are streaming this back across the ocean from Europe to everyone to see. And all these changes, as you saw, happening in real time. Why is this important? There are important reasons as far as development of the underground infrastructure. And we believe that, if we want to really join forces, I think a great example could be the UK experience, where they have brought together, I believe 80 plus utility companies, plus regulators, plus Geospatial Commission and many others. So to build a platform that allows for all of this stakeholders, so basically to contribute to the platform and not stepping on each other's toes, allowing proper access, each one responsible for their own platforms on one side, and also being able, if in case of telecoms, for example, there is sensitive information, that information can be allowed to be viewed only by the by the stakeholder that owns, operates that specific infrastructure, and can be also exposed to the others at the times when, for example, there are specific works ongoing around a specific location. So yeah, with that, we are almost at the end of our time, and please let us know if there are any questions, and we hope our presentation was as informative as your lunches, nutritive today. Yeah, you can contact us at huevo.com or on our LinkedIn and other pages, both personal and company. And yeah, please let us know if there are any specific questions.
So Antoine and Alex, thanks a million for that. That really gave us, I think, a really good perception of what's possible with a digital twin of above ground and below ground. One of the questions I have is this designed to share data between utilities, telecoms, municipalities, DOTs, MOTs? In other words, anybody who would be involved in, the use case we're pretty well focused on today is, construction, damage during construction, but these kinds of things can be also used for emergency preparedness. They can be used for a number of other use cases. In this case, is your focus primarily on damage prevention during construction, these use cases for digital twin, or are you really trying to come up with something that can be applied in with a number of different use cases?
So actually, what we are looking is not a specific use case, like you mentioned, in terms of damage prevention or emergency services, information provision, basically. But we are looking at our platform is that one source of information where all different contributors can bring their data. So whether you're doing a specific locate in a specific area, you can update that specific part of the model of the environment where you have found additional data, or you are a municipality that wants to make sure that their surveyors are on top of everything that is happening in their specific area, or a construction company. In addition to this, our environment allows what we call instances, which means everybody can have access to kind of a general environment. And then you can have specific instances that would be accessible to, for example, Department of Defense, if there are certain assets that they only them want to have in their own environment without access, providing access to anybody else, or strategic assets that somebody wants to make sure. And on top of that, you can also run different simulations in this environment. So whether those simulations would include simulating specific emergency events with potential evacuation scenarios and so on. So it's limited, in a way, it's limited really by your imagination, what kind of scenario you would like to implement.
So if we had a couple of utilities and telecoms, a municipal government, maybe a transportation authority and whatever, they all had their own data. Is it a thing where you just periodically upload data from each telecom or utility or MOT or whatever into the system, or does this system become basically the host for all of this data? Each utility or telecom or traffic authority or municipality is, the owner, responsible for their own data. Nobody else can change it. So I guess my question is it an upload periodically, every day or every month you upload fresh data from each of the utilities or telecoms, or is it something designed to reside in a common database, as you said, on AWS?
It's the same. So it is actually a platform that we believe that everybody should be able to use and have access to the most up-to-date information that exists. So if you're doing some works, you're repairing some damage on some street, as soon as that damage is repaired, the information is updated on the platform. So somebody else that comes there tomorrow, they have access to that information. And the ownership lies not with us, obviously, but with the asset owners and the asset operators. So we see this as a platform, as a consolidated three-dimensional database that allows you to not only track the assets, but also ongoing, kind of providing live to that digital twin. Because digital twins as a concept, right? You need to be able to consistently update them. If you are not updating them, they will lose their usefulness. And like in the examples in previous presentations, old that data is no data. So you want to make sure that what you see is a reliable information. So we believe that I will refer back to the example of the UK, where the regulators have mandated this large registry for everyone. The continuous maintenance of that registry not only helps individual operators, but it also helps everybody else who is dealing with infrastructure. In a way, we all already are on the ground physically, right, in the physical world. It's just digitally we're not there yet. So we are providing that platform to bring everybody else's data there.
Wonderful. Thank you very much for that explanation. I think that makes it much clearer what your architecture is.
Thank you very much for inviting us for the presentation.
Yeah, that was really an excellent presentation. So we're going to take a little break. We're going to be back at 1:35 for Jim Anspach to talk about what's happening at ASCE.